Okay, so in today's lecture, I want to cover the concrete classes that actually implement set. So we covered the interface of set and we talked how we can iterate over sets, but now I want to look at the actual classes that we can utilize to instantiate a set. There are three classes, the first of which is a hash set. So a quick overview of this slide deck. We're going to have an introduction into hash sets. We'll talk about the hierarchy of a hash set. We'll talk about the class declaration for a hash set and features. Then we'll look at the various constructors, the methods that are defined in hash sets, and then some code examples. So a quick introduction here. A hash set in Java is an unordered collection of elements that contains only unique elements, right? So it has to abide by what a set is defined as in an abstract sense. And so as we already know, duplicate free elements. So that is it allows duplicate free elements to be stored. Well, let's get rid of that. It's not needed. So here, so again, sets are unique elements and it's unordered. Those are the two big things. Internally, the hash set uses a hash table data structure to store a set of unique elements. And so hash tables are very fast, they're much faster and give a constant time performance for searching and retrieving elements. And so we'll talk a little bit about what a hash table is, which is why we can use the term hash set. So a quick explanation of the hierarchy here is that our hash set class extends the abstract set class right here, and which itself extends the abstract collection. And so here, the hash set also implements the set interface, and it implements the clonable and serializable marker interfaces. Recall that these marker interfaces don't have any methods. It just allows it to be a member of these two interfaces. And so serializable will give us the ability to have like data persistence, so we can store this in a file, and clonable will allow us to produce copies of this particular data collection. Okay. So let's take a quick look at the class declaration of HashSet. So HashSet is a concrete generic class, and it's declared as such. So you would have public class HashSet, and then it's generic. So inside of the angled brackets, we could define what element type would be stored inside this HashSet, and that way we still get the strong typing that Java affords us. And then it's going to extend the abstract set class, which is an abstract class. And then we'll also implement the set interface, the clonable interface, and the serializable interface. So the features of hash sets that you might want to be aware of is that one, the underlying data structure of a hash set is what's called a hash table. A hash table stores data by using a mechanism called hashing. Two, a hash set does not allow duplicate elements. If we try to add a duplicate element in the hash set, the older element would be overwritten. Three, it allows only one null element. If we try to add more than one null element, it would still return only one null. Four, hash set does not maintain any order in which elements are added. The order of the elements will be unpredictable. It will return in any random order. Five, it is much faster due to the hashing technique and gives a constant time performance for adding, retrieving, removing, contains, and size of operations. So hashing provides constant execution time for methods like add, remove, contains, and size, even for large sets. So when we talk about constant time, what that means in terms of like an algorithm analysis, and this is a concept you'll learn much deeper inside of data structures inside your next class. But the idea behind a constant time performance is no matter how large the set is, it takes the same amount of time to accomplish that method. So understand that that's not true for every type of operation. Like if you want to iterate over every element inside of a list, the amount of time it takes to do that on a very large list versus a very short list is going to be different. And so that is not the case with constant. It would be an operation in no matter what size the list is or set is, it would take the same amount of time to complete. 6, a hash set class is not synchronized, which means it's not thread safe. This is a concept that means little to us right now, but later when we talk about concurrency with things like networked applications, this is something you should be considerate of. Just understand that multiple threads can use the same hash set object at the same time, and so it will give a non-deterministic final output. So that can be very dangerous. If you want to synchronize a hash set, then the collections actually has a synchronized set method that you can use. And then the 7th feature here that you should be aware of is that the iterator returned by the HashSet class is fail fast, which means any modification that happened in the HashSet during iteration will throw that concurrent modification exception. So if we want to take an examination of the constructors of the HashSet class, well, we have the empty constructor, which is our default HashSet constructor. The default capacity is 16, and the syntax to create one is as such. So this is the non-generic version. Typically, you don't want to use the non-generic version. Understand it can be used, but then you have to do casting. This is the preferred form, the generic form, where T is the type of object that the hashtag will hold. And then we also have a second constructor where you can pass an integer value as the initial capacity. This initializes the capacity of the hash set. When the set capacity reaches full, a new element is added and the capacity of the hash set is expanded automatically. So just like an array list automatically grows, so does a hash set. So we can either use the default constructor, or we can define a size ahead of time if we know it's going to be bigger than 16, but it can grow organically throughout the life cycle of your application. So it's not like an array where when you define a capacity, it is set at that capacity, can't grow beyond that. So the internal structure will double in size before adding a new element, and the general syntax is as such. We have a third constructor that takes in 2 parameters, one which would be the initial capacity, and then the other would be a floating point number, which would be your fill ratio. So this form of the constructor initializes a capacity and a fill ratio. These are also called the load factor and load capacity of the hash set. Where the number of elements is greater than the capacity of the hash set, then the size of the hash set is grown, just like we had discussed previously, automatically by multiplying the capacity with the load factor. So the default value of the load factor is 0.75, and the value of the fill ratio range is between 0 to 1. So the general syntax to create an object is with the initial capacity and load factor would be as such. Here, an example, hash set on integers, HSet would be a new hash map where we pass in the initial capacity and then the fill ratio. So this would fill it back up as it expands by 70% effectively. And then the fourth constructor is just like all the other collections we saw up to this point. It has a constructor that you can pass in a collection, and it'll build a hash set from that collection that was passed in. So here it initializes your hash set by using the elements of C of another collection, and this constructor acts as a copy constructor. It copies elements from one collection to the newly created collection, and we cannot provide a custom initial capacity or fill ratio here. It'll use the defaults. So the original collection if the original collection had duplicate elements, only one of those elements will be allowed in the final set, right? So it adheres to the definition of what a set is. And the constructors that do not take a load factor, then 0.75 is used as the default load factor. And the methods for the hash set, so the Java HashSet class does not define any additional methods. it inherits the methods of its parent classes and methods of the implemented interface. So the various methods provided by its superclasses and interfaces are as follows. So HashSet itself doesn't have any methods, but it must either inherit abstract methods or it implements the ones from its interface. So we have an add method. So this allows us to add things into our HashSet. We have an add all method that allows us to add all the elements from some other collection into our HashSet. We have a remove method, and each of these, the add and add all, return back Boolean values, which will let you know whether the add was successful or not. We have a remove element where the HashSet will remove an object that based off of what the reference is passed in from the HashSet. And again, that will return back a Boolean value, letting you know whether that was successful or not. We have a clear method that will clear all the elements from a HashSet. We have a contains element that when an element is passed in, will return whether that element is inside the HashSet or not. We have the size of the HashSet, so that will return back an integer of how large your HashSet is, and then an is empty, which is a Boolean value that's returned whether there's elements or not in the HashSet. We have a clone method. And so since HashSet implements clonable interface, right, we said that that was one of the marker interfaces, we can create a shallow copy of that HashSet by simply calling clone method. We have an equals method. So we can pass in an object and it'll let us know if the object that was passed in is equal to this HashSet. And so equality is defined by whether the object that got passed in is a HashSet and also contains all the same set of elements that this current HashSet has. And then we have Hashcode. So the HashSet class overrides the Hashcode method to define an appropriate Hashcode value for the set. It returns the same Hashcode by sum up all hashcodes of all elements. So it determines its hashcode by taking the hashes of everything that's inside of it, which will produce a unique marker for this HashSet. Okay, let's look at some quick examples of this. So let's see how we can add an element to our HashSet. And instead of looking at a slide, let's jump back over to our IDE. So let's go here and we're on HashSet. So I'm going to click on HashSet tester here. And so here we're going to import our HashSet from java.util. We're going to create a class, HashSet tester1. We're going to create a main method so we can build an application out that actually uses HashSet. We'll create a new HashSet, and of course, we're going to use the generics form. Here, this HashSet will store string data types, and we'll just call this set and invoke the constructor. Then we're going to add some elements into our HashSet, so first, second, third, fourth, fifth. Then we'll add some duplicate elements, so first and third. We'll try to add null in twice. And then what we'll do is we'll just go ahead and print out the state of our HashSet after doing all of these operations. So let's go ahead and run this code. And here we see that we have the unordered and no duplicate HashSet elements. So notice there are no particular order. You know, HashSets, just like sets, interfaces claim is unordered. And they're all unique. So even when we try to add duplicated elements, only one instance appears. Okay, so, okay, let's see how we can add an entire collection to a HashSet. So again, instead of observing our source code on the slide, let's jump into our IDE. So here I'm going to open up HashSet tester 2. And inside HashSet tester 2, the other collection will be an array list. So I will take the contents of an array list and I'll insert all of them into my HashSet. So I'll also import HashSet. So let's create a class so we can create a main method. So we can try to do this. So the first thing we're going to do is we're going to create an empty array list that holds strings. We're going to add some elements in there. Here it's going to be Monday, Tuesday, Wednesday, Thursday, Friday. Then we're going to add 2 additional units. Now this is an array list. So an array list does support duplicated elements. So we're going to hold Monday and Friday as well. Then we're going to print out the state of our array list here. And then what we're going to do is we're going to build a new hash set, an empty hash set, and we're going to go ahead and pass our array list into our hash set with the add all method. Now, we could have also, when we did the constructor, pass our array list here as well, right? Because there is a fourth constructor. The fourth constructor we looked at can take in a collection. Or we can use an empty hash set and use the add all method and add all the elements from an array list like this. So there's two ways we could have gotten those elements from a collection into our hash set, and then we'll print out the hash set right there. So let's run that. And here we can see, again, we have, well, no, let's go here. Let's run that code. There we go. And we can see our original array list here is Monday, Tuesday, Wednesday, Thursday, Friday, Monday, Friday. And now once we convert it into a hash set, we see we've removed the duplicates for free, like Monday, Thursday, Friday, Wednesday, Tuesday. So this a good example when you'd want to use a hash set is if you do want unique values where you don't have to worry about duplications, instead of having to create logic to manage that yourself, you could just throw those elements into an array list, into a hash set, and then it'll do that for you. Then you'll have a unique set of elements. Okay, the next thing we should just take a quick examination into is how can we remove elements from our hash set using the methods that we learned about. So here we have a sample application. Let's actually look at it in real time. Open this up. So here I'll go ahead and import the hash set. Here I'll go ahead and define a class, HashSet tester3. I'll create a main method so that we can actually build an application out. And here we will create a hash set, an empty hash set that will hold integers. We'll add some integers, 5, 10, 15, 20. We'll print out the hash set, the initial set. Then what we'll do is we're going to go ahead and tell the hash set to remove an element, and it's going to look for the element 10 and remove it. So after removing the element, we're going to go ahead and print out the new state of the hash set. Then what we're going to do is we're going to create a second hash set that's empty. We're going to add two elements to it, 10 and 25. Then we're going to add all of those hash sets into there and print out the new state of our hash set. Then we're going to remove all the elements from hash set 2, the elements that are defined in hash set 2 from hash set, and then print out the new set. So here, there's two ways we can remove elements, right? We can remove an element one at a time, or we can remove multiple elements from a collection. So let's go ahead and run this. And here we can see we added 5, 10, 15, 20. So this is the initial state of our list. Then we're going to try to remove this 10 here. So after the removal of the 10, notice now it's 25, 15. Then the list of elements after adding elements is here. This is where we do the add all. So that's going to become 25, 25, 10, and 15. Then we're going to do the remove all here on line 25. And so HashSet 2 had 10 and 25. So you're going to see here, we're going to go from here to here. We're going to move that 10 and 25. And then after we go ahead and invoke the clear method that removes everything, then you see it's now an empty hash set. Okay, so the next thing I want to do here is I want to check the size of the hash set. So let's build a simple application that invokes the size method. So this is very small, short application. Let's go and open it up in our IDE. So I'm going to import the hash set concrete class, and I'm going to import the set class, the set interface. Then I'm going to create a class HashSet tester4. I'm going to create a main method so we can actually build out an application. First thing I'm going to do is I'm going to actually create a HashSet instance, but I'm going to save it as a set. That's why I imported set here. So this is going to be at the data access type of set. And then here, since set has the methods, the abstract methods is empty and size, we can call it from there. So here, the first thing we're going to do is we're going to ask, is it empty? So we're going to get back either a true, false response. And then we're going to go ahead and get the size, the initial size. Then we're going to add some data into our hash set, and then we'll get the new size. So we should see that our size will go ahead and grow out as the life cycle of our application progresses. So is the popular country set empty? Yes, it is. And then the number of countries in hash set before adding is 0, and the number of countries in the hash set after adding is 4. And then our fifth example, we're going to try to check whether the hash set contains a particular element. So let's jump over into our hash set tester. And here we have, we're going to import hash set, we're going to import set, we're going to create a class and a main method so we can build an application. Here we're going to create as a data type set, a new hash set that holds strings. We're going to find out if it's empty. We're going to check the size. We're going to add data into there. This time it's going to be currency values. Then what we're going to do is we're going to then check the state of our set. Then we're going to check the size of our set. Then we're going to evaluate. We'll do a selection statement. If our set contains the element dollar inside of it, we will print out this body here that does element dollar exist in set? Yes, element dollar does exist in set. And if it doesn't, then we'll go ahead and print no element of dollar exists in set. Now we clearly added dollar, so we should get the if statement to print out. And then what we'll do is we'll see if the set contains dinar. It does not, right? We have dollar, rupee, euro, and yen. So this will not toggle into the if selection. It'll go to the else clause here. So it should print out no element dinar does not exist. So again, what's cool about being able to use sets here is you can check to see if it contains an element and then direct the next phase of your logic based off of the set of elements that are contained inside of there. So say, for instance, you were building a game and you had like quest flags to determine whether you advance to the next part of the quest or not. You might manage your quest flags inside of a set. And you're like, well, if the quest log contains like this flag, then move to this part of the game. Otherwise, give them this other message. Okay, let's go ahead and run. Oh, no. Not what I wanted. Back my projects. Okay, let's go ahead and run that. And here you can see the set is empty. It starts at size 0. We then add elements, the yen, dollar, Indian rupee, and euro, which now has 4 elements. Does the element dollar exist? Yes, it does. Does the element dinar exist? No, it does not. So see how easy it is to use these frameworks to build up relatively complex data structures or collections. And finally, for at least this particular concrete class, let's take a look at how we can create user-defined objects for our hash set. So let's jump over into our final one here. That's not quite. Oh, here. So let's open this. Okay, perfect. So here inside of HashSet Tester 6, notice I'm actually going to have 2 classes defined inside of one source code file. So just illustrating, we can do this. So we're going to use our own user-defined data, which will be a student. So a student will just be have a name and then a student name and then an ID number. So we'll have our name, our surname, and our ID. And then here you can see inside of our hash set, we'll import hash set inside of our class HashSet tester. We're going to make a main method. Here we're going to make a new hash set. And here, notice inside the angle brackets, you can use whatever data type you have created. So we create a student data type, so we can now have a hash set for students. And then we're going to create 3 new student instances, S1, S2, and S3, that we're going to give a name, and then a name, and then a ID. And then we will add those into our hash sets, and then we can iterate and see, hey, look, we have each of our students in there, in our set of students. And here you can see we iterate and have them all there. So this is just an illustration that you can use your own custom classes for these hash sets, just like an array list. And so the last thing I kind of want to cover with this particular concrete of hash set is when you might want to consider using a hash set to manage your data. So there's 4 considerations you might want to think about. One, when you don't want to store duplicate elements, hash sets are a great choice. 2, when you want to remove duplicate elements from a list, you could do that very easily with a hash set. 3, hash set is preferred when you want to add or remove operations are more abundant as opposed to your get operations. So adding and removing is very quick in a hash set as opposed to getting a particular operation. So if you're doing a lot of writing into your collection and not necessarily a lot of reading. And then finally, we are not working in a multi-threaded environment. So if you are working in a multi-threaded environment, then you don't want to use a hash set at all because it's not serialized. You don't want to use anything that's not, that's not, that doesn't allow you to play with thread safety. Excellent. And so that is everything I have to say about the concrete class hash set that implements the set interface. It's just one of 3 classes, and they all have different behaviors.